All right, we have a full agenda. I'm Mike Jones. I'm here as a in-person proxy for the OAUTH chairs. Hannes, a chair, is with us. Deb, our area director, is with us. I am going to be brutal about ending presentations on time so that we do get through those that are scheduled. If any of you finish early, that would be wonderful. With that, please take it away, Hannes, for the chair's presentation. You are muted, Hannes.
Thanks, Mike. Hi, everyone. Welcome to this IETF 125 meeting. Sorry that I couldn't be there, job change related. Mike, can you skip to the next slide? So this is the note well, which you have seen before. I would like to request you that you act professionally in all the discussions and follow the usual process rules. Next slide. If you are in the room and you want to go to the microphone, please make sure that you use the Meet Echo client to join the queue, and so we can identify you and have you correctly noted in the meeting minutes. Oh, speaking about meeting minutes, Mike, do we have someone?
We do not yet, to my knowledge.
Oops.
This is the time during which you will be rewarded with the thanks of the working group for going to the meeting chat client or to the meeting note-taking client and helping us out. Preferably, I'd like to have at least 2 people doing this so that you can tag team each other. Who in the room is willing to go to the note-taking tool and participate? We can't have the meeting without this.
I can definitely take some notes, so that's no problem. But if there's someone else, that would be great. I think there's one person in the queue who might be willing to help handling one. That's great. Or just use Ecker's AI tool, if I would know how to do that.
So handling one, you're acknowledged.
Okay, perfect. Next slide. So quick update. You may have seen from the list that we had 2 documents in the RC editor queue, which is the browser-based applications document and also the best current practices for the trust device flow security. So that should become RC anytime soon. We have also one document in ISG evaluation, which is the token status list, and and 2 other documents in AD evaluation. Next slide, Mike. As you said already, Mike, there is a pretty full agenda, and I won't read this to you. Everyone knows on who is going to talk next. So let's keep it going.
Aaron, you are up. Let me try to find your slides. There we go. And do you want to use the clicker yourself?
Can you put a timer on the screen as well for me?
I don't know.
Okay, I'll try to manage it.
How much time
all
do you
right.
want to give them?
10 minutes each.
10 minutes each. I don't know how to do the timer function.
Thanks. Hi, Aaron Parecki. Got a lot to cover today, but I'm looking forward to it. We're going to start with OAuth 2.1, which I'm sure by now you're all tired of hearing about. I am too. That was a photo from the one of the metro lines I took on the way over here. So really quick, the reason for OAuth 2.1 is because the current state of OAuth 2.0 has gotten kind of messy. It's described in a bunch of different RFCs and extensions, and some of them are very nearly complete now. We've kind of collected a set of what we consider to be the core, what we mean by current best practices of OAuth 2, which is the path towards OAuth 2.1. So this is the goal, is to capture the best practices that are in these documents, laid out in these documents, and not to define any new behavior. So the good news is that two of the ones that we've been waiting on for a while are very nearly complete. RFC 9700 was published a year ago, and browser-based applications is now in the queue for publication. I wanted to quickly recap a couple of the changes since the last draft, and then talk about some of the current open questions I'm hoping to resolve. Thanks, Philip, for a couple of these PRs. These were a couple of the errata from RFC 6749 have now been applied into this. That seems like a good chance to do that kind of work. There was some effort to sync the language from RFC 9700 around open redirects. So that's now been ported into 2.1. There's also additional context for the JOT client authentication, and a mention to specifically follow the recommended practices in RFC 7523 BIS, which is also an in progress but nearly complete document. As always, every time we go through any of these, there's always room to improve. So lots of editorial clarifications and updates that hopefully make it easier to read. There are a handful of open issues on the draft. Other than the couple I've flagged here, I feel like we've actually talked about quite a lot of these in past meetings, even if we haven't yet completed the text to address them. If you do, please do give these a read and chime in with your thoughts on any of these that are still tagged as being open. But a couple of them I want to call out today for discussion with the few minutes we have here. One of them is issue 233. If you are in the slides, these link out to the issue on GitHub for the full context. I realize this is a lot of text on the slide. I'm not going to read it all, but TLDR, RFC 9207 defines the ISS authorization response parameter, and one of the reasons for doing it, and one of the reasons it became, it was so quickly in RFC, was because it's a relatively straightforward mechanism to solve a couple of clear mix-up attacks. And the alternative solution to that, which is using distinct redirect URLs per authorization server. So this is essentially when a client talks to multiple authorization servers, as many do, you need to mitigate this kind of mix-up attack. You can do it either through ISS or through distinct redirect URIs. Some ecosystems that regularly interact with multiple ASs do not have the option to use distinct redirect URIs. For example, clients using client ID metadata document, or clients that are MCP clients, because they don't have a pre-established relationship with the authorization server. So the question here is, should ISS be incorporated into 2.1 as a required response parameter for the authorization server? The main justification for doing that is that it's easy for the authorization server to add it. It is not a complicated mechanism. And for clients that don't need it, they can just ignore it, the same as they would ignore any other parameter coming back. The main benefit of doing this is that ecosystems that have this problem, that need to solve this mix-up attack, don't have to make the decision on their own about whether to require it or whether to leave it unresolved. And many of them look to the OAuth working group as experts on how to do OAuth securely, and would benefit from a clear stance on this parameter. I'm going to go through the other slides before I invite comments, but please do feel free to queue up, and I want to have some discussion about these. But I do want to also flag the other ones so that we don't spend too much time on only one of them. The other big question here I wanted to call out is PXE. PXE defines SHA-256 and plain as challenge modes, plain being there is no transformation of the PXE challenge. Are we still online? Okay. So the question here is, should we forbid the plain challenge in OAuth 2.1 because it does not provide the full protection that a SHA-256 does for PXE. One benefit would be there's no ambiguity for doing so. Clients can just do SHA-256 and not have to figure out whether to do it. The main justification for doing it is that one of the primary reason for including plain in PXE at all was because of the constrained environments that OAuth was being deployed in 2015, some of which did not have SHA-256 functions. However, it is now 11 years later, and that is not really the case anymore. Anything that can do HTTPS, in particular the requirements of HTTPS that OAuth 2.1 requires, will have a hash function on the device somewhere. So it's not really a burden. Are we totally offline?
We were good until a few seconds ago. I was showing you the presentation on my screen.
Okay. So that's the spiel on PXE. I'm gonna. Oh,
we can still hear you though.
Okay.
Okay.
Great. We don't have any time to waste, so I'm gonna keep going.
Yeah, keep going.
But I do need to look at my next slide. Unless anybody has comments, in which case, I think the audio is still working. So any discussion on those two is welcome until I get the slides back.
This is John Bradley. Definitely get rid of plain.
Thank you.
Ka-Shun Lu.
Kai-Shun Luo here from Chinese University of Hong Kong. So for the mix-up question, mandating issuer parameter, my take is that I support it, but I think we might encounter some difficulties for a client to actually use that return issuer to mitigate mix-up. Mainly because like for an issue identifier to be trustworthy, you need to, the client needs to make sure that, well, that identifier is fetched from metadata beforehand. But not every client with a server actually use metadata in the first place, because I think it is still optional in OAuth 2.1 for now. So that may hinder real world clients from using that mandated identifier for mix-up mitigation.
So you're basically saying that only including it in the response is not enough. You have to also tell clients to start the discovery from that identifier in the first place.
Yep. There might be some other band opportunities like to make that identifier trustworthy, but that is not documented in any spec. So yeah, in real world, that is a big barrier, I think.
Okay.
But I think, say for MCP or some other FAPI, I believe other ecosystems, since that AES metadata is already enforced, it is already mandated, then for those ecosystems, mandating ISS is actually like the two combined together, you can have a robust mix-up mitigation.
Yeah, so, okay, that makes sense. So the, I realized those were my two issues. So yeah, I don't have another slide. Yeah, that's a good point. So maybe the answer then is to include more guidance on, like make it, my main goal here is I want to remove the ambiguity and the decision-making process from the communities that will have this problem and give them clear guidance. So if that guidance is the scenario you just described of when you are driving the discovery from the authorization server issuer, then the issuer response is required, and then clients validate it. That is a clear end-to-end picture, but that doesn't necessarily make it required for everyone.
Yeah, I believe there's a distinction between just using multiple ASs that you hard code and having discovered authorization servers that the user drives. the discovery of. We've been through this with 7523 bis, where comparing issuer values only really works if the client goes through RFC 8414 discovery or OpenID Connect one. And subsequently, after fetching the metadata document, also confirms the issuer that it gets from the response is the one that it expects based on what the input to discovery was.
Okay.
Okay, one more, and then we're going to switch presentations.
Sorry, was that one more question on the queue?
I think the queue is now drained. The person didn't remove themselves.
Oh, okay.
Um,
So that was, yeah, those are the two issues I wanted to discuss. There are some other open issues on GitHub. Please feel free to chime in on those. But with the resolution to these two, I am going to post the next version of that and see you next time.
All right, client ID metadata document.
Okay, how do we do this with the room not being able to see the slides?
I hate to say this, but if you join the client in the room, you can see the slides, but please keep your audio.
Great point.
Off.
Yeah, if you use the Meet Echo Lite client, or it's called on-site tool in Meet Echo, you can grab that on your computer and see the slides.
Yep.
Okay, thanks.
Right, and you can see the slides from my.
Yeah, and I've got this one too.
All right.
Great. So yeah, client ID metadata document. You can't see the nice photo I took at sunset of the city, but hopefully you can see it on your computers. I want to go really quickly through the, oh, you have to give the control to the slides again. It's a clicker. Really quickly want to recap the motivation for this and what this is before getting into a couple of the questions. So the idea with client ID metadata document is it's a way for a client to publish the metadata about itself at a URL using the vocabulary that's defined in dynamic client registration. So it's a JSON document hosted at a URL that contains properties like the client name, redirect URIs, et cetera, et cetera.
The clicker is gone from my menu. I can advance the slide manually.
Okay.
No, yeah, the clicker's on the switch, so you'll get it eventually.
Oh, it's connected to the room stuff, right, which is not
Okay.
online.
All right, next slide.
Yes.
Okay.
Thanks. That's what I just said. Oh, yes. So after the client publishes its metadata in a JSON document, it then uses that URL as the client ID in an authorization request. Next slide. Why is this needed? It's needed in the cases where pre-registration of clients isn't possible because the client developer does not have a prior relationship with the authorization server it's talking to. For example, open source apps talking to self-hosted services, or as we all know and love, AI. MCP clients have the same problem where the MCP client can talk to servers it has not seen before. So next slide. What is new since last time we talked? Next slide. This draft is now actually referenced by MCP, the MCP spec. That spec has its own standards org and lifecycle, and they now reference the spec as the recommended way for MCP clients to talk and do their OAuth flows. Next slide. Oh, that was November that was published. Changes since this version. A lot of the changes. So last time we met was the call for adoption was like in progress, so I was holding off on actually applying changes to the document until we got through that. Now it is an adopted draft, and I've gone back through all the feedback that we gathered during the call for adoption and have applied most of it. A lot of it is guidance and security considerations. So things like when an authorization server supports both registered and unregistered clients. There we go. Additional SSRF security considerations, things like authenticate the user before you fetch the metadata and avoid fetching special use IP ranges. Thank you. An important one is prohibiting following redirects when fetching, in other words, requiring HTTP 200 response. since there should not be a valid reason to follow redirects. There are still a couple open issues, but I want to again call out a couple of the key ones here to discuss. I'm going to again try to summarize them very quickly and then open the room for discussion on any of these if you feel like it. There is a PR, number 50, linked in the slides, which proposes that URLs like client URI, logo URI, have to be HTTPS URLs. One of the reasons for doing this was to avoid issues like when there are weird URI schemes like JavaScript or a shortcuts scheme, if the authorization server ever actually renders these links into a web interface somewhere. However, that does prevent optimizations like including a data URI with an image that's kind of embedded in the metadata rather than linked to. So the question is this PR a good idea, or should this instead be more like a security consideration around fetching data from untrusted sources, or should this be HTTPS or data URIs are the only allowed schemes? So that's one issue. We seem to have lost slides again. The next one to cover is JWKS versus JWKS URI in the metadata. There's currently no guidance on this. Basically, both properties are valid properties in dynamic client registration. There's two ways the client can publish its keys: embed the key in the metadata or link to it. Should there be a recommendation? Or should this be left to ecosystems to decide whether they want to make a recommendation or requirement? Or should this be a requirement like authorization servers have to support both so that clients can choose? Essentially, there is no guidance on this right now. I feel like there should be some guidance or requirement somewhere on this. Not sure where this actually lands. And then the third one is content type header, which I'm not a content type expert by any means. I know there are people here who are, so please, your input is welcome. This is on the SSRF question of how can we make it less of a problem when the server goes and fetches the metadata from a URL it's never seen before. If the server includes a content type header, then the server can early reject requests that might be malformed, like if someone puts in a image URL as a client ID that's never going to work, we can avoid the server having to respond with a document before it can reject it. There's quite a bit of discussion on this already in an issue and PR, but this gets into the kind of hairy details around content types around, is it application JSON? Is it a more specific CIMD? Is it, you can read the details there. That's definitely looking for support on that one. And then the last one is client versions. This is also a little messy. There is a software version property in the dynamic client registration vocabulary. So technically a client can publish a version number in its metadata right now, but there's no discussion on what that means or how to deal with it or how to process it. So again, we can just say it's not the job of this draft to do anything, just like it isn't the job of DCR to do anything about this, or we could try to describe some mechanism to link versions of clients using this property. There's many different ways that could work. Some of them are interesting, some of them are odd. So input is welcome there. With our 2 minutes, if anybody has some burning points, fiery points to make on any of these 4 issues, your comments are very welcome.
Michael, announce yourself, by the way.
Hi, Michael Fraser from Radium. Since there was nothing else in the queue, this isn't to do with any of those forums, sorry, so I'll keep it quick. This is the point I made earlier, and I'd like to clarify because I made it poorly. In OpenID Federation, we have a very similar sort of scenario. I'm not going to talk about policies here or anything, but we have the scenario where a document will leave metadata, but it's a client ID, it uses the basic client stuff. It also includes guidance to go and look at the OpenID Connect Relay and Party Metadata Choices document for metadata that has a single value but might exist in an ecosystem where servers can support multiple things. So for example, token...
Closer to the microphone, Michael.
Sorry, token endpoint authentication mechanism. It's a single value, but it might exist in an ecosystem where a server can support one or another or another. So while nothing in this document prohibits anything in that, it might be worth including some specific guidance highlighting that this is a good idea in such a scenario. Yeah, thank you.
Okay, thank you.
Anyone else? If not, we're going to go to first-party apps a minute early.
I queued, I'll use the 36 seconds, maybe it didn't show up. Is it on the JDBcast URI question, is there any real reason to support just plain JWKS? Some of the original thinking, and I know it's a little bit different in this context, but the original idea was to separate something that's likely to change often, which is keys, from sort of like the base set of metadata, and allow for lookups based on changing key IDs or whatever to occur more frequently, independent of the things that might change very infrequently. And this kind of smashes those together, but it feels like just sticking to that would be better. That's sort of a half-formed thought, but.
Yeah, I agree. It seems cleaner. I think if I remember the discussion that's happened on the GitHub, the reason for it in the first place was that it's a possible optimization and that it's already in the wild in some places. So, yeah.
Fair enough. And just be careful with the media type stuff. I saw bits of that, but if there's optimizations there, great, or things that are helpful, great, but don't do things that are gonna cause interoperability problems, like requiring a specific media type to be sent one way or the other. I get a bad feeling from that. Thank you.
Okay.
Okay, I'm having tooling problem now. It says all the slots for the requested media are already taken. Yeah, how? No, that's leave room. Maybe take control away from the slide clicker. Okay, now I can do it. Okay, unless I'm the clicker. So first-party apps, correct?
Yep.
Okay.
All right. We're gonna do the same thing here. This, I think, should be a quick one, I hope. So I'm not going to go into the whole background on why this draft exists, but it is in the slide deck if you are curious. So OAuth for first-party apps essentially is a draft that enables developers who are, I need the control again.
Okay.
Developers who are building native apps, or in particular first-party native apps, to have a better experience than using the web in-app web view that appears in mobile apps that is currently recommended in RFC 8252.
You should have control.
Thank you. And the reason that this is useful for us to solve is because people are doing terrible things without this. Very, very wonderful hacks around the solution. So this has been in the works for a while now. We've been discussing it at these meetings since October 2024. It's gone through several iterations, got a lot of feedback on it. There's been actually quite a lot of implementations of it as well that we've seen. Since the last time we met in the last fall, we have gone through and addressed and closed 34 of the issues that were open, which is very nearly all of them. Many of these were slight language tweaks that we've incorporated. Some of them were a little more functional. So I've called out like the major ones that we've changed since then. One of them was adding response type code as a required parameter, since it's required in 6749, and this endpoint is supposed to kind of mirror that. A significant change is around the requirements for the text that says how auth session is bound to a device. It was previously must. The comments were basically, you can't make it a must if you don't tell us how to do it. So it's a should, and there is now a reference to Depop as a way to do that. lots and lots of editorial clarification, and an important one that is not really normative is the introduction and the kind of framing the context for the need of this. The language we kind of toned down and said it's intended for first-party applications, but it can be extended for third-party use cases if you are willing to describe the reason why it's not problematic to do so. And that was actually based on the presentation from Yaron last fall around the native app-to-app federation, which we will see a presentation on shortly, where he's able to now extend this draft to enable that use case. So there are two profiles of this already in the works. There's the passkey authentication, passkey method of using this, which is currently sitting at a pull request, which needs to be brought into its own doc. But that's going to be that's its own document, as a profile of this. Then there's also the native apps using federation doc, which was created out of the discussion from last IETF. And there's a session on that later today as well. The last remaining issue that we were not able to just close out by making quick changes was the question of whether this draft should actually be defined as an extension of push authorization requests or not. After doing some thinking with the group of editors, we've landed on this take. In order to do this, the response from PAR would actually need to be extended to include other parameters, things like the error codes or the authorization code. PAR does not provide that mechanism. PAR is a very specific, tightly scoped definition of there's parameters here that get encapsulated in a request URI that essentially references those values. So we recommend that we do not attempt to extend PAR for this draft. For that reason, as well as this actually has quite a lot of deployments, and it seems to be successful as is. So with all of that, we feel like it's at the point where we can ask for working group last call on this. There are already several implementations of this in the wild. There is a lot of interest in developing interoperability profiles based on this, and we have addressed and closed all but that one issue on PAR. So I'm hoping to close out the PAR issue here today and hopefully ask for working group last call.
This is where I'm not the chair. Hannes, do you want to say something about the idea of working group last call?
If the authors/editors of the document think it's ready for working group last call, we'll issue one. Of course, it would be nice to resolve that open issue on the bar first. And I guess that's why Brian is on a microphone for that.
Brian?
I realize my enthusiastic hand gestures probably didn't go on record, but I very much support the decision that was made in that last issue of recommending against PAR or just not at all. But, yeah.
Thank you, Brian. Anyone else?
Doesn't look so. Aaron, what are you planning to do on the bar issue now, in light of moving forward to working group last call?
Yeah, if there's general agreement that there's no interest in pursuing reworking this draft to extend PAR somehow, that's great. Essentially, no action is needed, and we will close the issue, and we are happy with the current state of the draft.
Okay.
Does anyone in the room or online want to speak against that path forward? Seeing no hands in the queue.
Okay.
All right.
That's a plan.
Now that I know how to take control back from the clicker, I will end this presentation. And we will share the next one, which is the identity assertion authorization, correct?
Yeah.
And let me give control to the clicker. Your show.
There we go. Thank you. All right. All right, last one for me. Then I stop talking for a while. We'll see. We'll see. This is a view out my hotel window from earlier this week. All right. Identity assertion authorization grant. Again, real quick on the background because we don't have time to get into the whole motivation for it. But this is an extension of or a profile of the identity and authorization chaining across domains draft. Wanted to show you kind of the timeline of how these have been progressing for a while now. The core of the problem is to extend single sign-on in an enterprise context to API access in an enterprise. And yes, we all love our AI use cases, so I've used it as an example here. However, it is not only for AI use cases, and that's very important. It applies to any kind of app-to-app connection under an enterprise scenario. Essentially, the problem is that when one of these apps that it does single sign-on wants to get data from another app, they do an OAuth flow with the user, and the IDP is kind of cut out of the picture and doesn't see anything. It's also a lot of prompts that the user has to click through in order to agree to these connections, these OAuth connections. So essentially, we extend the idea of single sign-on to API access. You can think of it as API access single sign-on. The two main benefits is it reduces user friction and it enables the enterprise control of that data sharing between apps, which is a very important thing that customers care about. The building blocks for this are token exchange and the JOT authorization grant, which are combined into the identity chaining document. That's where this kind of combination of them is defined. And then we've profiled that further to define this thing. Oops, you can't see the slides in the room anymore. No, that screen's down. That one's working. Great. This document is the document that defines the concept of this ID JAG, the identity assertion JOT authorization grant. I'm not going to go through the whole exchange, but here it is. You can review that on your own. This is what the ID JAG looks like. It's essentially a JOT that represents the enterprise IDPs saying that it's okay for one app to access a user's data in another application. So what is new since the last time we met? There are now a handful of new in-progress implementations. Some of them are open source, some of them are closed source. And MCP also references this as an authorization extension in that last November update. A couple of the changes in the doc. A couple of the changes in the doc are based on the most common feedback we've gotten from implementers as they've been working on this. One is the question of what about Depop? It's possible to apply Depop in the token exchange and JOT authorization grant. It doesn't really require very much new in order to do that. It does require mentioning that the ID JAG can contain the Depop proof hash thing. I don't remember exactly what it's called. It's in the draft. Another question is, how does this work with RAR? And again, it's kind of a natural evolution to apply RAR in this way, but it does mean that we need to define, to say that it's okay for this ID JAG to contain a RAR authorization object, which there's nothing stopping you from doing that, but now there's an example of how to do that in the draft. One of the bigger changes is adding a refresh token as an input subject token type. So essentially, now a client can either present an ID token because they just did single sign-on, or present a refresh token that they would have gotten through OpenID Connect single sign-on as a way to continue to get access through this enterprise IDP, even if the ID token's already expired. And again, we did this for two reasons. One, because one of the first questions we got was, what happens if I want to get access a day after the user's logged in and the ID token's expired? We don't want people to be validating or accepting expired ID tokens. That seems like a bad path to go down. So we said, let's apply refresh tokens. Also, this enables exchanging a SAML assertion for a refresh token, and then you kind of get out of the SAML world fast and into OpenID Connect and OAuth, and you can now use this with the SAML SSO connection. There's another, one of the relatively big changes is this mechanism to support multi-tenant systems, which is a very mind-bending concept to get around, and it takes a long time every time I try to load up the issue into my head. So hopefully it is now captured in the draft. So here's, I should have just gone through these when I was describing that. Here's the Depop example. Here's the RAR example. Here's the refresh token subject example. And here's the multi-tenant example with this very helpful picture. Find me later if you want me to go through this. It makes sense if once you think about it long enough. So yeah, with that, the this one actually defines a new claim. It defines these two new claims. The subject token input type. Again, the refresh token subject token type is not new. It's already there. It's always been an input to token exchange. The use of it here is new. So it's not exactly a normative change, but it kind of is. It's at least significant. Other than that, all of these things are like these have all been editorial or just adding examples. So, and the remaining issues on this are questions about the draft or editorial clarifications, which I admit can always be improved. But at this point, we are not expecting any major changes in this draft. And I don't have any open issues to discuss here. Wanted to just present this state of things. And if anybody has comments on these recent changes, comments are welcome.
So meta question, what do you think the next steps are for the draft?
Next steps for the draft, I would like to do at least one more editorial pass on it, because again, you can always improve the language and explanations. If anything is confusing about this as you go and read it, please let me know, file an issue, or just come find me. I want to clarify that. But I don't expect to do any more significant mechanical work on the draft. So I'm hoping to do some editorial cleanups and then working group last call on this probably in a little while.
Pamela.
Quick question, and it's really early in the morning here, so if I've messed this up, I apologize. Is there some name disambiguation that needs to happen with something called XAA?
Oh, yes. So early in the draft, you'll see a mention of this referred to as cross-app access as like an informal name for what this enables. The XAA acronym is a shortening of the term cross-app access. This is not really well defined in the draft. Probably could be mentioned better. But it's in the intro, and it's when it talks about the problem statement of like what we're trying to do is enable. Where's my little picture of the enterprise? We're trying to enable this kind of cross-app access in an enterprise. So that's a good call out. I will take that as an issue to try to better clarify that and maybe actually use the acronym in here, since it's kind of just evolved as a natural occurrence of people talking about it.
Any other thoughts? Hannes, do you want to speak?
Can you hear me?
Now we can.
Okay. Maybe we can get some reviewers from the room to have a look at this document, because it looks like a little further along already, and from your description, it almost sounds like might be ready for working group last call pretty soon.
I would love to get some reviewers for this.
Mike, do you see some hands in the room?
Yes, please put your names in the chat for the
Oh,
note
that's a good
taker.
idea. Please, yeah.
I saw one. Is there another
Justin, yeah.
volunteer?
Mhm.
Surely there must be someone else interested in implementing this that would like to get it right first.
Okay, so far I have Justin. I don't know if there's someone in the room. Oh, okay, you're on.
Okay, we have two.
And Antoine,
Wanna
thank you. Yes.
Thanks.
Take control over the slides.
Great timing.
We will move on. Thank you for your timely marathon sequence of presentations.
I think I ended right on time. Thank you.
Yep. All right, updates to OAuth 2.0 security. And I will give you control of the clicker.
Good afternoon, everyone. I'm Kai-Xiong Luo from the Chinese University of Hong Kong. I'm a PhD candidate there. So today I'm going to present updates to OAuth 2.0 Security BCP on behalf of my co-authors, Tim, Pedram, and Adonis. So here's a bit of background history. This draft documents several new attacks since the RFC 9700 has been published. We held interim meetings on these issues last year and also discussed at OSW and the past IETF meetings. The first issue is the audience injection attack, and the second is some security issues on account linking, or as Aaron put it, app-to-app OAuth connections. And in last October, the working group adoption call is issued, and here we are after the adoption. So the expectation that's accumulated based on previous working group feedback is that, like, first of all, it's not meant to replace 9700. It's meant to coexist with it because there could be multiple security BCP RFCs under the same BCP number. And as best current practice, probably we need not hold until all of these new attacks come out, but we can keep a small focus stock to publish. So let's go into the details. Audience injection attack. So basically, an attacker-controlled authorization server can reuse a client assertion at an honest authorization server so as to impersonate the client. And these spec updates are partially handled by the RFC 75-23 BIS document, which is submitted to IESG for publication now, but that spec only talks about how RFC 75-23 shall be updated. It does not mention how the attack actually works. It does not specify other affected standards and alternative mitigations. For example, not using the issue identifier as the audience value, but to use exact URI of the target endpoint. So this document is a security-specific, security-centric perspective for the problem, including both the attack as well as the countermeasures. And the second issue is we call it cross-toolkit OAuth account takeover or code. So the background on this is that, like, existing security guidance on mix-up attacks in RFC 9700 relies on the issue identifier to uniquely identify an authorization server and to avoid confusion. For example, we can take a look at the right-hand side figure. So first of all, the client needs to store an issue identifier, say attacker.com. And now if an honest AS return the auth code together with an issuer equals honest.com, then the client should figure out, oh, there's something going on. There's something wrong going on. So it could avoid the auth code being forwarded to the wrong attacker-controlled AS. But in real-world deployments, we find that actually the issue identifier may not be available if 9207 RFC is not used. The stored issuer at the client side may not be trusted if the RFC 8414, the AS metadata is not used, but the client instead relies on manually configured AS endpoints. And the issue identifier also may not be unique. So these hinder real-world vendors from applying the issuer-based defense. And actually, based on our investigation, none of the 20+ vendors, client vendors we investigate did. So, but on the other hand, real-world attacks are actually very prevalent because the core attack precondition of mix-up that there are multiple authorization servers connecting to a client and then one of them is malicious can be easily satisfied in certain open ecosystems. For example, certain cloud platforms for app integrations has an open marketplace for sales integrations, also called connectors these days. Or most recently in Agent AI, there are these multi-tenant token bots where each tenant can equip its applications or AI agent with custom toolkits. So basically, malicious authorization servers can be introduced via these integrations, connectors, or toolkits, causing unauthorized access or account takeover. And to this end, we have found like more than 20 vulnerable vendors across the industry, including Microsoft, Amazon, Google, and a lot others. So in this document, section 2.2, we try to provide a self-contained section that model these common latest deployment scenarios and provide a generalized attack description under the name cross-toolkit, OAuth account takeover, or code. And we provide a handy countermeasure that an OAuth client can readily apply to protect existing OAuth deployments, meaning that like they don't need any OAuth extension RFCs, but those that are already compliant were only compliant with RFC 67549 can already deploy these as mix-up countermeasures. Specifically, it means that it's not using the issue identifier, but instead a client-assigned identifier for each integration connector or toolkit. So it could be always available, trusted, and unique. We embed that identifier in the URI and then match it during OAuth flows at the client. So in the draft, we further delineate in what cases the issue identifier, namely the existing mix-up countermeasures, are still useful and preferred, and correct some misconceptions. So the third issue and final issue here is called cross-user OAuth session fixation. So a bit of background here, session fixation is actually a known threat in a lot of OAuth ecosystem or OAuth-derived ecosystems, such as OpenID for verifiable presentations, OAuth cross-device flows, as well as OAuth 1.0. Basically, an attacker can trick a victim into authorizing an OAuth flow that's initiated by the attacker. So what gets fixated in the victim's user agent is an attacker-controlled auth session. So after the victim's authorization, actually, it is the attacker that gains access to the victim's protected resources. Well, in theory, OAuth 2.0 authorization code grant actually mitigates session fixation because it's not inventing the concept of auth session in the first place, but only leaves the state parameter in OAuth that can somehow maintain application state. But even that state should be securely bound to the user agent session. And as a result, in RFC 9700, this session fixation threat is not even there. It's not discussed, and it only mentions CSRF, where the state parameter is used as a CSRF token. So in reality, we see that many vendors actually introduce standalone auth sessions because they need to carry application state, especially to track like which end user at the client would eventually get the access token. And these auth sessions are often introduced either in the state parameter or they would use some standalone URL query parameters in some other requests in the OAuth. So, and it turns out that like during the process, clients often fail to bind auth sessions to their user agent session that will cause session fixation. And it's not just like careless implementation flaws, but we find that it's often because of the clients are unable to bind securely, do the binding themselves, because oftentimes OAuth responsibilities and session management are actually decoupled at the client. They are handled by separate components at the client, either because they are handled in separate web origins, they are handled in different user agents, say a mobile app with a confidential client wants to request authorization from an external user agent, or simply because in the token vaults use case, like the OAuth responsibilities of the application is outsourced to a centralized party. So in these use cases, session fixation is feasible by simply sharing the request URL that contains that session to a victim user. And we have found even more than 40 vulnerable vendors across the ecosystem. And this is just a lower bound. So in section 2.3 of this draft, we try to similarly model these common deployment scenarios to provide attack descriptions of session fixation, as well as propose countermeasures. And the crux is that like a client needs to validate the binding of the auth session to any existing user session at the client. But in order to do so, the client may further need to say first return to the web origin or user agent where there is the client's original session. And in the spec, we further delineate the attack's relationship with, say, CSRF and why Pixie cannot solve the problem alone.
1 minute.
Sure. So here are the document updates since working group adoption. Basically, no new contents are added, but we made several clarifications about the text and yeah, path forward. First and foremost, comments on the draft content are greatly appreciated. Here's the data tracker link, and we also have a GitHub repo where you feel free to leave comments there. And just recap the expectation, I think we plan to collect some feedback on the draft and incorporate it, resolve other issues there are before the next IETF meeting. And hopefully we can discuss any remaining issues there, and depending on the feedback, see what's the appropriate next steps. So thank you, and that's all from my presentation.
Hannes, would you like to say a few words?
Yeah, I think so. Yeah, thanks for the work. I thought it was really interesting when you talked about the mix-up attack. At the time when it was published, it was ahead of its time in some sense, because there's the use case that it targeted or exploited with multiple authorizations, so it wasn't all that common back then.
Yep.
But then it took us years to work out the solution with the issuer identifier. And it does, from your presentation, it sounds like we prematurely came to a conclusion that that is the right solution, which is sounded a little bit like you are saying, well, probably not.
I would say
Which
it's
is
still the
which is
right
unfortunate.
solution as long as or if everybody's standards compliant. But in reality, if the client is not or the AS is not, then you'll still get into trouble. And so we have some kind of like alternative solution for this.
Yeah, yeah. So definitely we need to have more look at this, because of course, if companies and deployments don't decide not to use your variant either, then we are also toast, right? So that's a little tricky. So I guess we definitely need some reviewers to look into this. Also, I think the title of the document needs a little bit of sharpening, because I think it has a very generic name that may be missed by many readers, I fear. But maybe there are also some ideas from reviewers on how to find a better, more modern title.
Thanks, Hannes.
Mike, if you find some people in the room to review that one, I think that could help us move the document forward. Because there's obviously, this is complicated stuff. There's a lot of details that need to be looked into. So it's probably not something for beginners, I fear.
Can people both raise their hands and put their name in the chat so that the note taker can capture your name as a potential reviewer? Aaron, you seem like you'd be a good reviewer. Are you willing? Aaron succumbed to peer pressure.
Thank you.
Brian, you seem like you'd be a good reviewer. Are you willing to succumb to peer pressure? Okay, thank you. Anyone else is welcome to do that. I do not have a deck that I can find for the SPIFFE authentication topic. Was none submitted?
Michael,
Yeah,
can you try to refresh,
yeah.
please?
I approved it. So there should be the deck there, but it may be a lag in refreshing it or so.
The title may not correspond then. We're burning time now.
I can see it at all the way to the end of the
If
list.
you can see it, you submit it for presentation now. Okay.
Oh, Ant is doing it, so just
Aren't
approve it.
asked to share the slides. There we go. Okay.
Okay, I can't see it either. I'll try to refresh.
Okay, unless I can't see it either. Are you able to see it?
Okay, I'm going to let you work that out in the background. Let's proceed to the RAR metadata presentation. You're on, you're on. Yaron, are you with us?
Hi, I'm with you. Can you hear me? And can I get
Yes, now
clicker
we can hear you.
control?
I'll reset the timer to 10 minutes.
Okay, how do I control the slides or just take me to the next one? Okay, yeah, got it. So hi everyone, Jeroen Zahavi from Vienna, and this is about RAR metadata, and we like RAR, we use it in banking. We know it's being used in healthcare. I'll show some examples from Health ID from Norway in my presentation. Takahiko Kawasaki from OAUTH brought about CEDAR policies in RAR, so it's a great draft. And the limitation we want to discuss today is that it has very limited metadata. The RAR RFC only provides that the authorization server can say which types it supports, but there's no indication about what these types mean, how are they constructed, and then what's the relationship to resource servers, which types do they expect, and for which resources. And so we propose adding metadata through a new authorization server endpoint that describes those types. So per type mentioned in the type supported, you'd have an instance here in the response of this metadata saying that, for example, payment initiation has a certain description, additional documentation URI, a schema either directly or as a URI, and examples. So this is the authorization server side of things. And we also propose additional resource server error signaling. So through a normative error, the resource server could say, I'm rejecting this as forbidden because of insufficient authorization details. And then together with the resource metadata URI, RFC 9728, this could lead to additional discovery where the client calls then this resource URI and in the response obtains a new attribute that details which authorization details types are supported by the endpoint. So each resource can say, and with certain operators, I require one of these types or all of the other types or different constraints. And then this way, client can go to the supporting authorization servers, discover the details type metadata endpoint, call it, and understand how to construct those types. So this is a metadata discovery. And if we look at the example from Norway, Rune Grimsted was very kind to support. This is the actual requirement. So for a specific endpoint that he provided, it would need two RAR types in combination. One identifies the vendor, and the second one identifies the type of request being made to the healthcare system. They have a specific challenge where they have 300 healthcare providers that connect to this open API platform and write software, and all need to know these relationships of how to construct the RAR types and which RAR types each resource endpoint expects. And then the next part is an optional part. This is a different pattern that says, what if the resource server, in addition to saying this is an insufficient RAR kind of error, and here's my resource metadata, and you can learn and discover how to construct, but what if it would actually provide an informative response body with the actual RAR object that's actionable? So if the client takes this object, makes a new auth request with it, and the end user approves and the token is being issued, this is going to satisfy the endpoint upon next call. So this is an optional informative mode for full remediation. So the idea is that the client just uses this in the next request. We in Raiffeisen Bank International use this pattern already. We didn't want the clients to deal with learning the resource domain RAR objects and what they mean, but we just say you failed, this is why you failed, and that's what you got to do to go and fix it. We find that it has additional benefits. It enables the resource server to enrich the structure. It might have ephemeral data, such as transaction IDs, or flags that guide the authorization server and say, you know, the risk level is so and so, so I'm instructing on different ceremonies that I, as the resource server, attach to that transaction. It can add cryptographic checksums to this RAR payload, or do whatever it can. So in this type of optional pattern, the resource domain wants to control the RAR body, and we use it, and it's also garnered interest from MCP working group working on fine-grained authorization. So the idea is that an MCP client would attempt to call tools with an initial OAuth token obtained at login time. And then if the resource being called requires an approval, it will instruct on remediation and say you failed because of authorization required. And there's a hint, this is a RAR type, and this is what you need to request. So this type of pattern has taken already some interest there. And so, yeah, this is the feedback we got. So Helse ID from Norway is interested in the metadata discovery use case. The metadata actionable RAR object use case, we use it in Raiffeisen, and the MCP working group on authorization, on fine-grained authorization, is interested in it as well. And that's all I had in terms of slides. And I'm, since this is a new draft, I'm requesting feedback on this.
Has anybody read the draft? Justin, you're acknowledged.
I have not read the draft, but I have a question for the presenter. Is there, have considerations been made regarding having this turn into an unwitting oracle, especially when you're returning detail from the resource in what is effectively an insufficiently authorized state?
I'm not sure I got the question. What do you mean by turning it into an oracle?
Oh, okay. So I have software and I'm not allowed to get the data, but by telling me what I need to in order to get the data, there's a risk of leaking internal state information and basically giving me additional leverage that I might use in order to pursue an attack.
Mm-hmm. Yeah, so the draft has security considerations talking about the external authorization model represented in the RAR objects versus the internal one. So the basic idea is that not to expose too much, right? To be aware of those risks. And I assume you're referring to this pattern here, where the authorization server
Right,
actually
yeah.
provides the actionable one. Okay, yeah. Then of course the risk is here, but the assumption is that if an ecosystem uses RAR, then there are objects out there, and there needs to be discovery of how to construct them anyway. So the level of documentation is there. So the first pattern already standardizes the discovery path, and these objects already need to be designed with security in mind. Of course, once these objects require more, present higher risks, then
Did I lose you, or was it your?
Ron, we have lost your audio.
Okay.
While we wait for Yaron's audio, let me take the cue. Pam?
do you hear me now?
Yeah, now I can hear you. Continue.
Okay, sorry. Where was I lost? Where did you lose me?
I think that you sufficiently answered the question that I was after. Obviously, as a new draft, this is one avenue that we can pursue if the working group picks this up. Overall, I do think this is great. This is addressing a bunch of stuff that we very intentionally punted on during RAR in order to keep it tighter and simpler. The discovery issue is its own, can of worms. So I'm excited to see this addressed in its own body of work.
Pam?
Hello. Is there a plan to address the common schema issue here? Because the way that this works, the clients, every client would need to know every custom authorization details payload for every API they call. So there's a proliferation issue, I think, but has that been discussed?
It's not been discussed, but happy to explore it further with you. Happy to connect. My understanding is that the proliferation issue exists the moment that RAR was put out there, and each ecosystem has its types. This draft attempts to put forward a metadata and discovery of. So it does not challenge the proliferation itself, but tries to put order into things.
Okay, thank you. Look forward to discussing it.
Aaron? And Pam, are you willing to review the draft?
Yes, I am.
Thank
Absolutely.
you. Let the record show. Aaron?
Just really quick, I did review the draft. Generally, I think this is something that's needed. One thing that made me a little bit nervous is the whole expression syntax bit where it's defining the all of or one of or and or things like that. In JSON, I'm wondering if there's some other existing thing that can be referenced that does that instead of defining it all in this draft.
Happy to look for something like that. Will do.
Okay, Yaron, proceed with your next presentation. If you can share that, that would be great.
Okay. Can you share it for me and give me control
Yes,
again, please?
Find it. I think I found it. Okay, there you go.
Do I have control?
No, that's why I was asking you to share it. Let me see if I
But
can
since
do
you're
it.
You can give him control. I can give him control, but then
Okay,
remind me
what-
to take it back.
Okay,
Okay, thank you. So as Aaron reminded previously, this is a profile based on first-party apps developed together. And the recap comes to the two previous IETFs, where I came up with a draft tackling app-to-app flows with a federation across trust domains, resulting in using the browser and a degraded non-native user experience. Our challenge comes when a client app here on the left side, needs to achieve an authorization flow with an app here on the right side, but they're not directly connected. There's an n number of brokers, meaning authorization servers that federate to the next authorization servers. Since these trust domains A until N are not served by any app, the experience is no longer native, and the navigation is through a browser, and this contains a number of challenges. We've encountered these challenges in our setup in Raiffeisen Bank International, but also learned that the Swiss government has this. In our use case, we have 10 subsidiaries here on the right side in Central and Eastern Europe, and we're trying to reuse client apps for various reasons, stock trading, crypto trading, gold trading, whatever. And we want to build them once and use them across the countries, but then to consume the IDPs and the login flows on each app, we use a broker, and then our flow falls to the browser. This was our challenge. Working on it, we got contacted by the Swiss government, and without going into detail, they have the same pattern with apps on the left side, authentication apps on the right side, and a broker. So we're in the same pattern. And in the previous IETF, we presented, again, our draft, and it contains a new endpoint, OAuth as an API. And then Aaron was kind enough to say, have you considered first-party apps? And we've interacted, and we said, okay, but ours is not a first-party use case, it's with federation. But Aaron said, my draft is already direct OAuth interaction as an API. we could use that endpoint and build a profile upon it. And so we did. And this draft builds and extends FIPA with new responses. There's the federate response, where a client talks to an authorization server in a FIPA request. And the authorization server here in 2 says, I want you to federate. Here's my auth session. Here's where I want to get a response. But you should go to the next authorization server, and here's my FIPA request to it. And the client complies and calls the next authorization server on behalf of the previous. And that one, let's imagine that goes through the actual first-party app ceremonies and authorizes the request, ending up with an authorization code. But this code is intended not for the client, but for the previous one. So the client kindly acts like the browser would in a 302 redirect flow, but just building those ceremonies onto first-party apps using the security mechanisms in there. So then when the client provides the code, then the original authorization server is happy and can finish the flow. So with this option, first-party apps becomes a native interaction that can federate across authorization servers. And then the next command is redirect to app. So when the client makes the request, if it's a mobile native app client, it would include the native callback URI. That's an indication of where it wants to get responses. That's the client's own deep link, and any authorization server that does federate must forward this parameter, so it's kept in the context. And then the authorization server or anyone in the flow says, I want you to use the app. So I don't want to serve you the challenges directly. I want you to use an app that I'm instructing with the deep link. And the client does so. And then after this app interacts, it provides on this callback URI the authorization code. And then the client can feed back the code to the authorization server and complete the ceremony with the help of an app. So these two flows already achieve our use case and the Swiss government use case, because we can federate across authorization servers natively, and we can interact with additional apps natively, and all within the constructs of first-party apps. And then another third type of interaction we introduced is the insufficient information. This is when the authorization server is not sure where to federate to. It has more than one option, and it can challenge the client and say, I need more information, and I'd like you to prompt the user and ask them for their email. Because once I know the email, I know the trust domain, and I know which IDP to choose, and I'll know the next instruction. So there is some language here to prompt the user and say, enter your email, or in the next example, a multi-value choice. So choose your bank, and here are 2 values. And the client then renders this choice, gets the response, gives it back to the authorization server, and this way goes back to one of the previous responses. Okay, so if I know where you're going, I know where to federate you, or which app to use. And another security realization Aaron and I have made is that when a client is federating, so in this flow, this client is calling AS2, which it has no relationship to. It has no standing in it. So it's a client of AS1, but it's making calls to AS2. And AS2 knows 1, but doesn't know the client. So how does client authenticate, right? Because first-party app says client should authenticate, and there needs to be a strong trust relationship. And so the understanding was that the only thing the client actually has here to show is a PAR request URI. So whenever there's a federation, the usage of PAR, then the request URI generated by PAR is an indication that there was a trust relationship and a request was created here. So whenever federating, it must be done using PAR. That's the one thing. And when the client then obtains, when AS2 obtains here a request, and it knows through some metadata that this is a federating, AS1 is going to federate clients, it should be careful about the challenges it serves to the client. So it would be a bad idea if AS2 would say to the client, please give me a username and password, because we don't want the password, for example, to flow through the client. So this is the consideration about these clients. And yeah, that's all I have for you. Happy to take questions and comments, and happy to ask for reviews.
Standard question, has anybody read the draft? Would anybody be willing to read the draft? Aaron, you're an author, right? Is there anybody in the room you'd like to suggest should read it? Okay, put your name in the chat again, please. We got a volunteer.
Perfect. And for what it's worth, I think I managed to refresh the repository, so you should see on slides now.
Okay, if that's the case, let's try to use Arndt's presentation. I found something with spiffy in the title. That's probably it.
Yeah, that's
All right,
it.
proceed.
Thank you. So this is an update on the SPIFFE client authentication. On behalf of my co-authors, Stein, Scott, and Peter, presenting this today. This got adopted between the last IETF and this one. Yeah, small recap. SPIFFE stands for Secure Production Identity Framework for Everyone. It's part of the Cloud Native Compute Foundation, and it targets an identity framework for workloads. In SPIFFE, our credentials are referred to as SVIDs, single verifiable identity documents. And until now, we always had two SVIDs, the X509 format and the JOT format. And since not so long ago, we are adding the workload entity token format, which comes out of the WMC working group at IETF. Yeah, it's used in the industry, mainly in enterprise environments. Added a couple of links there. Yeah, so today, if workloads act as OAuth clients, there is this following situation that they can use SPIFFE to talk to other workloads, they most of the time use with mutual TLS, with X509, or just basic bearer off with JOT. But if they want to start talking to an OAuth authorization server, most of the time they end up using client ID and secret, basically private key shorts, auth. Yeah, and it's a bit of a shame because this secret needs to be manually provisioned and rotated. It's long-lived. It's a bearer credential after all. But the workloads, they have those shortly rotated, automatically provisioned credentials already, and they just simply cannot use them so far. Yeah, this is how often configuration looks like. One is on the left is Java Spring Boot, and on the right is some .NET. And most of the time you would see there's some client secret or some client secret reference to a vault. Yeah, so our goal in this draft is to have a profile for OAuth that allows you to use your SPIFFE credential, your SPIFFE SVID. You already rotate every hour to use against your OAuth authorization server. Yeah, so the proposal proposes 3 parts, one for each credential format. For the JOT SVID, we basically profile 7521, which is the OAuth assertion framework. This is the client authentication part of it, not the assertion part of it. The JOT SVID is a bearer, shows a token, carries subject, audience, and time to live. The X509 one profiles 8705. That's the mutual TLS client authentication part, already adopted. And since last IETF and since the adoption, we also added the workload entity token profile, which uses the attestation-based client auth draft, which is currently, I think, already quite far ahead, if not even in working group last call. This worker identity token carries the CNF claim and has proof of key capabilities, or as a proof of key bound token, and we use the attestation-based client auth to provide the proof. Yeah, since last IETF and adoption, we kind of went around the other OAuth work and thought, okay, where can we align? One of it, as I just mentioned, is the attestation-based client authentication, which is currently a draft. Thanks to Yara and Taka, we also added support for the CIMD spec, and we also added token endpoint auth method supported, which is the authorization server metadata. Is the authorization server metadata property one of those? And we are proposing 3 types: SPIFFy short, SPIFFy X509, SPIFFy worker identity token. Yeah, this is now our goal, since we got adopted, to look around OAuth and see, okay, where do we need alignment? Yeah, and that's also our goal and some sort of timeline. This whole thing got proposed or started to being discussed early 2025. Now we are early 26 at IETF 125, and our goal is to finish alignment with all the other parts of OAuth and also finalize the draft by the next IETF. Yeah, so if you have interest in this work, please reach out, please provide a review. Yeah, we are trying to use momentum in the space and want to get this, go through soon. Yeah. And
Thank you. Who
that
has
is
read
it.
the draft? Aaron has read the draft. Who is willing to read the draft? 2 hands went up. Please put your names in the chat for the note takers. Others are always willing. We are 5 minutes behind time, so unless there's any other comments, I'm going to end it here, and we will move on to the additional hash algorithms draft, which Aaron is going to present in person. Giving it to the clicker.
Thanks. All right. Hi, Aaron Parecki again. I'm actually presenting this on behalf of Philip, who is remote and, on the screen there. Fantastic.
Hi, Philip.
So the core problem here is that there are a lot of places in OAuth that hardcode specific mentions of SHA-256, some of which have extension points defined, some of which do not. However, there's often no mention about other hash algorithms. These are a few places where this happens. This is mostly fine for most things. And in the places where, for example, Pixie that uses SHA-256, we don't expect that the actual hash method is broken in any significant way that it causes any real problems. However, there are some places that define requirements on cryptography, in particular CNSA 2.0, that specifically prohibit the use of SHA-256 because in some cases it is considered to be too weak. And it's a blanket ban on the hash algorithm. And they require more bits. So essentially what it means is that in those cases, when you have to follow those regulations, you are unable to even use Pixie as it's described today with SHA-256 or MTLS or Depop. So this draft, all it does is it defines SHA-512 alternatives for where SHA-256 is currently defined, so that in places that can't use 256, there is an option and a well-defined mechanism to use 512. It does not deprecate SHA-256. It does not try to step into saying that you shouldn't use it elsewhere. It's specifically for the use cases of when you can't use it because of your regulatory environment. There is a mention of it, even saying that you should not use it unless you absolutely have to. There is negotiation and metadata in most of these places to allow this kind of multiple algorithms coexisting if we ever did need to backwards or deprecate 256. So here, this is like a summary of essentially what's in the draft of where the what mechanism in OAuth uses SHA-256 currently, and then what it would be with 512 and where. For discovery and negotiation, there's the AS metadata that calls out where, like, which code challenge methods are supported, but there is some missing places where discovery and negotiation is missing in the current draft. So those are also defined. It's like defining these in the appropriate registries for this. So there's a few things added to RS metadata. There's a thing added to the Depop registry. And essentially it says if these are absent, the default is SHA-256, which is essentially the current state. So I see Brian's making some faces, which makes me nervous. But yes, essentially the action here is call for reviews. Please give this a read. Again, keeping in mind that the scope of this is for the people who are unable to use SHA-256 for regulatory reasons, because there is a broad statement that says you can't use this method. This should provide them a path to use the rest of OAuth as opposed to, for example, not using Depop or using the plain Pixie method, which it sounds crazy, but essentially that is the only option otherwise, because if you can't use SHA-256, you have to just not use it. So we're trying to give people a better path for that when they have to.
Well,
That's the end. That's the
Aaron
last
has
slide.
asked the key question. I just volunteered in the chat. I think Fleming raised his hand, is going to the microphone.
Hello. I have a question regarding this draft. I actually read it this time. In fact, it's very specific to SHA beyond 256. And I think that maybe the problem with the rise that for regulatory reason, you need to use another additional hash, and then you go back to requiring to do such of draft again. And I think the very interesting part in the draft is a negotiation of the hash algorithm that you want to use in the authentication. And I think that we should have a draft with fixing the parts of the different protocol methods that don't have this negotiation capability, and then leave open to someone else the responsibility for designing whichever hash-based method he wants to use, because then you can have something that is done in a very smaller scope rather than requiring all the machinery of negotiation once again for an additional hash mechanism.
So additional hash mechanism, I already got 2 backchannel messages about adding SHA-3 and adding shake-based options. The point behind keeping the draft limited was to just open up the way for CNSA 2.0 to continue, which was a choice between SHA-384 and 512, because under CNSA 2.0, SHA-3 is only allowed for signing firmware and hardware. It's not allowed as a general hashing algorithm. And the extension points and the discoverability is there, that it can be then reused with any future algorithm.
And I think I would even narrow deeper and just do the negotiation and specifying the policy and requirements on both ends to have a sort of ladder of hash mechanisms that you want to use. And use SHA-256 as mandatory to implement or very baseline algorithm for some cases, and then do something specific for the hash after.
Okay, thank you.
Antoine, you're next in the queue. Brian, you're apparently next in the queue.
I was gonna maybe go the other way.
Closer to the mic.
Sorry. some of the faces that we're making were largely around the negotiation pieces. And if I understand the goal here, it's to fit within the constructs of a very tightly regulated world. And I would like to understand the actual rationale behind it, if you could explain that to me another time. But I don't think the negotiation pieces are necessary or even realistic to follow, and I would drop that entirely and just allow for the new places you've identified to carry the new hash. And if you need it, you just do it, and if you don't, you ignore it. And just for whatever it's worth, those were designed as extension points through the inclusion of exactly what you did, a new claim, a new parameter. That was an intentional decision to facilitate agility and extensibility through the providing something with a new name, not necessarily a deficiency around like not having a method and the way that Pixie did. I had something else I was gonna say, but that's all.
Justin?
Big plus one to what Brian just said. The structures that you guys are extending were intended to be extended exactly how you're extending them, and so this is. I don't see this as a gap in that it lacks negotiation. I see it as a feature that it lacks negotiation. Because the reality is, in a lot of these cases, especially in highly regulated environments, you don't want negotiation. You want a single configuration, and it's set a certain way, and it only ever does that. Too loose algorithm negotiation got us JOTs without none that were being accepted in places where they shouldn't be, because hey, the algorithm is right there. I can just plug that into my list of supported algorithms and it just goes. And yes, that is an extreme example. It's reducio ad absurdum. However, that is the pattern that was being intentionally avoided here with especially things like ATH and in Depop and whatnot. So yeah, I agree that we don't particularly need to build out negotiation for these pieces, but I do think that adding these hash definitions is fantastic, and I think we should do that.
So as we're running out of time, I will quickly speak to why that negotiation is there, and that is me coming from the point of view of having a client that I do not want to have a specific flag that says only use SHA-512. So it needs those hints in order to figure out which one to use. But I get the feedback, I get the point, and I would welcome you to review, put it on the list so that we can discuss further.
Okay.
Thank you.
Thanks, guys. And our chair reminds us that what we're trying to do in the next set of presentations is to determine reviewers. So if you can, in the chat, pre-review or pre-select yourself to review, that would be super to move us along. Next, we have the OAuth extension for multi-agent collaboration.
Okay, hello everyone. I'm going to present a proposal for OAuth extension for working for the multi-agent collaboration scenarios.
Giving you the control.
Okay.
And if you can do this in shorter than 10 minutes, it would let us probably do another presentation.
Okay, I'll try my best.
Thank you.
So here is the background of our research. The core idea is currently the AI models often involve some complex tasks. It exceeds the single agent capability. So to address this, there may be multi-specialized AI agents collaborate with each other to accomplish one task. In this scenario, often there is a leading agent to coordinate the sub-agents to form a specialized task group. So take an example, the task A may be a real-time health advice. So it is not a single task. It needs the collaboration of the data collection, status prediction, and some advice generation agents. So this collaboration may introduce some authorization challenges. For example, if each sub-agent in a task group apply for access token individually, it will cause some inefficiency because of frequent interaction with the authorization server. And the second, for the authorization server, managing the permissions for potentially dynamic task group is a little difficult. And what's more, it may involve some lack of clear traceability for the actions performed by the task group. So traditional authorization procedure is for an individual client application, or let's say the clients with the same permissions. However, on the right side is a multi-agent collaboration workflows. We can see the leading agent may receive an intent from the user and resolve the intent to generate a task. And then it can use the task to discover some sub-agents and resource servers from the discovery services. This part is out of the authorization. But then the leading agent may assign the task to the sub-agents, and the leading agent and sub-agents will form a task group. When executing the task, this task group may need to invoke some resource servers for resources. So authorization is happening here. So our solution is to propose a task group authorization. We have two methods. The first one is a static task group, where the leading agent may select the sub-agents ahead of the task execution. And the second method is a dynamic task group authorization, where the leading agent may choose the sub-agent one by one, and the new sub-agents may join the task group. So let's see the static method first. The core idea is the leading agent may act as the applier of the access token and request that access token from the authorization server on behalf of the whole task group. So in the this is the access token of the static method. We want to add a new claim, maybe called the applier, to indicate the applier of the access token. In our proposal, it's the leading agent ID. And what's more, there may be multiple subject, audience, and scope pairs, which each indicates a sub-agent's permission. And now let's take a look at the dynamic task group authorization. So in this case, the leading agent first obtains an access token, and then it will select a sub-agent dynamically. After that, it will generate a task credential and send the access token with the task credential to the sub-agent. And the access token and task credential is cryptographically bound with each other. So the access token in this case is, here is an example. We want to add a new additional claim called attribute to indicate the attribute of the sub-agent. In our case, is a task ID. And what's more, the subject claim in the access token may be reused to index the keys that will be used to endorse the attribute. So what is the task credential involved in this procedure? Here is an example. The task credential is lightweight credential issued by the leading agent to the sub-agent, and it will contain the leading agent's ID, task ID, sub-agent ID, and maybe the hash of the related access token. And what's more, the signature of the task credential is generated by the leading agent using the key we just included in the access token. And after the sub-agent receive the access token and task credential, it may provide these two things to the resource server to request a service. So on the resource server side, it needs to verify the access token first, like OAuth defined, and then it needs to verify the task credentials, validity or signature. And then what's more, it needs to verify the relationship of the task token and the task credential. For example, it may extract the public keys from the access token and use it to verify the signature of the task credential. And what's more, access token may involve a task ID. The resource server should verify that the task ID is the same as what is included in the task credential. So you may see that our method of dynamic task group is inspired by the depop method. Here is a comparison of the two methods. So the depop is cryptographically binds the access token to client public keys, and in our method, the access token is bundled to the client's attribute. And in depop, the credential is a public key credential, also issued by a CA, and in our proposal, the credential is an attribute credential issued by the leading agent. And then this is a conclusion of our proposed two authorization method, the static and dynamic one. So the static one is suitable for the predefined task or a predictable task with a fixed task group. And dynamic method is suitable for a dynamic task. Both of them can improve the efficiency. So here is the advantages of our proposal, like improve the efficiency, flexibility, and simplify the management. So to conclude, we propose a multi-agent collaboration authorization methods, like two methods. One is a static one, another is a dynamic one. And also we have some questions like, is there any existing authorization method or suitable for the multi-agent collaboration? And is it feasible to extend the access token with a player or attribute claim? Or we can reuse some existing parameters. That's all, thank you.
Peter?
Okay. In your task, you're trying to use an attribute to describe a task. And to me, that it may require additional syntax or parsing mechanisms. So can you know, explain that a little bit? How do you use an attribute to describe a task?
Okay, task may be described with a natural language sentence like I want health advice from my agent. Also, it can be a task unique identifier. And in our proposal, we think the attribute the attribute credential is issued by the leading agent, because the leading agent can decide the task from the intent and assign the task to the sub-agent. So the leading agent may be the issuer of the attributes.
Okay, we're at time. Who is willing to review this draft? Peter? Aaron? Thank you. Others are always welcome. With that, thank you. We will move on now to the agent-to-agent profile for transaction tokens.
Hello, everyone. I'm Yuan Ni. Today, my presentation is about transaction token profiles for agent-to-agent calls. Transaction token is a short-lived signed JOT which is designed to maintain and propagate the identity and context throughout the service core chain. What we want to do is to extend this mechanism to an agent-to-agent scenario. To protect the user and agent identity, authorization context, as well as the agent-to-agent context. So why is this necessary? The OWASP Top 10 for agentic AI applications has illustrated that there are several critical risks in the case of multi-agent workflow, such as the goal hijack, context poisoning, and privilege abuse. We believe transaction token is a powerful way to solve these problems because, firstly, transaction token can preserve the user identity and authorization context to avoid any deviation from the user's intent. Moreover, it is short-lived and downscoping, so it can prevent privilege abuse and matches the agent nature. Last but not least, we want to use transaction token to protect the agent-to-agent context to prevent context poisoning and rot. How to realize these goals? Transaction tokens has introduced several changeable and immutable data fields. Let's first make a quick overview of them. The first one is scope. It is the immutable purpose of the transaction. And the second one is transaction context. It contains the immutable details throughout the core chain. And the last one is request context. It corresponds to the changeable environmental context. What we do is just encapsulate the agent-to-agent message structures into the transaction token claims. For example, we map the task ID and the user input into the immutable data fields, such as the scope and the transaction context. And we map the agent thinking status updates, such as context ID, max ID, to the request context. So here comes two questions we really want feedback on. The first one is where should the scope comes from? The first option is just to put the task ID into the scope. And the second option is we let the scope derive from the external access token scope and put task ID in the request context. The second question is, should we introduce a new claim to carry the agent-to-agent context, for example, the agent context, or just directly use the existing request context? Finally, I want to mention that we have made a discussion with Ashley, the author of the transaction tokens for agents. We're both interested in transaction tokens for AI agent applications. So there may be a potential for merging in the future. That's all for my presentation.
All right, I know there's advocates for transaction tokens. Is one of you willing to, or several of you willing to review? Transaction token draft. Who would like to look at it for the working group? Hank, you are recognized in the queue.
Yeah, hi, this is Hank. Not immediately in the next 2 or 3 weeks, but I will do it in the next 6 weeks.
We have a volunteer. Thank you.
Okay.
Anyone else? And I'm going to change decks now. If you're going to volunteer, you can do so in the chat, as I've been asking people to do. Thank you very much. We're going to move on to the agent operation authorization presentation.
Okay, I'm not sure whether my co-author Rashi is here. So I assume not. Then I will do the presentation on behalf of our co-authors. So what is the problem we want to solve? So the first one is the authentication framework for the agentic environment. So for example, if you imagine open cloud like agent, you cannot know what the agent actually do, because the agent has some capabilities to extend their skills. So we cannot do the authentication based on pre-configured policy. So the policy could be dynamic, generated by the agent. That is one thing. Another is that the agent itself, due to the hallucination of the LLM nature, maybe not accurate reflect the user's intention. So we need some kind of mechanism for the user's consent with what the agent actually want to do. So that is one thing. Another is delegation. So the delegation, including the which agent delegate which user and do what kind of behavior, and also delegate the intention of the agent, whether the user agree with the agent's path of the user intention. So that is the delegation. So our solution here is not to reinvent any new wheel. We understand that OAuth working group and community has built a lot of very good standards, and we read very carefully of the draft that Brian published days ago, and we want to follow that architecture. We want to define minimal extensions about the claims and the token format to enable the interoperability of the agent ecosystem. So the mechanism is quite simple. We reuse the push authorization request standard and put agent operation proposal claim there. So in this proposal, the agent, for example, wanted to propose to band the user identity and the agent identity together, and to band with proposed behavior, for example, buy something cheap on November 11, something like that. And also, so with this mechanism, the authentication server can first verify whether this is a policy is allowed, and secondly, can redirect to the user for users authentication and consent and authorization. And after that, the AS will generate evidence claim, which is as a witness of the AS, the bonding is approved. So it's basically as at the bottom line of this slide, it basically says that, okay, the authorization, both the authorization server and the user agree that this agent on behalf of this user and do this behavior, and this is allowed. So the security model here, first we think that due to the hallucination and promote injection, we cannot trust what LLM says. That is the drift from the user intention. But our assumption is that the agent runtime, the agent code can be trusted.
Okay, we're going to stop so we get one more presentation.
Sure.
Who is willing to review this? Aaron, Peter, thank you. Put your names in the chat. Next, we will move on to the life cycle for RAR. Is the presenter in the room, Mei Ling?
Is the person in the room?
Yes.
Oh, cool.
Okay. It is not letting me present slides anymore. Let me try. Deb or Hannes, are you able to present slides? Justin just asked to share slides.
I can't for some reason. It's funny if Justin can. Justin, did you hack the system? Justin, are you trying to share something?
I was just seeing if it would let me share the slides for some bizarre reason.
Okay, that's weird. Yeah, it's an authorization problem, I would think so.
There we go.
Yeah. Thanks.
Okay, I'm giving it to the clicker.
Yeah, I'm very quick. Okay, mention from China Mobile. Okay, sorry. We have two drafts here. Is that the first is for we want to extend the RAR with two new members. Is because by the ambiguous authorization request and the static lifetime. So we add the two new members here. The first object is post context, and the second is the lifetime life cycle bounding. I'll have a quick look here. Is that post context? We add the parameters here is assurance level, compliance framework, and the risk signals here with IP address, devices ID, and the lifecycle bounding here is a type, task ID, notification, endpoint URI method, and also terminal states is very simple introduction here because we have another draft.
Mei-Ling, we're at time. What would you like people to know in the last minute?
Yeah, I want people to know that now the OAuth is not enough for the AI agents authorization. Yeah. We have to do more things for the fine-grained authorization access.
Okay, that's a good statement. Who would like to review Mei-Ling's draft that is about that? Aaron again, and I saw Hank's hand move. So let's put Hank down and
No, not so big promises on this one.
okay. And let's see, we also had Fleming, yes? Okay, thank you all for moving with us at such a pace. We have a lot going on. There's at least 3 other drafts that we have not discussed. They are in the data tracker. Nothing prevents you from reading them and reviewing without presentations having occurred. Thank you all. Have a good afternoon.
Let's
And
say
thank you all
for advisement. We have that meeting tomorrow on 10:30 on Hunan that meeting room. Thank you. The topic is AI agent authentication and authorization. Welcome. Thank you.
And a thank you from my side as well. And in the next couple of months, we'll schedule some virtual intro meetings to discuss these topics, and of course, try to wrap up our working group documents as well. So we'll be fine. Thank you all.
All right.
Hannes, will you call for more topics on the interims and not just these ones? Because there's more that we didn't cover.
Of course.
Okay, thank you.
All right. Active session. Thank you. Bye-bye.